Hello students, and welcome to today's lesson, which will serve as an introduction to probability. Our essential questions for today are: what is probability? What key vocabulary is used when discussing probability? This will give you a foundation for lessons to come, and we will also look at how we define or determine what the sample space of an experiment is. You've seen probabilities in your real life many times. Every time you watch the weather forecast, you see a probability, the likelihood that it's going to rain in a given day. Here you can see that Wednesday on this forecast has a 60% chance of rain. Did you know that people actually calculate the probability of getting struck by lightning? In Wyoming, you have a 2/10 chance of being struck by lightning. A total of 14 people in that 13-year range were struck by lightning out of the total population. Or maybe you know someone who has bought a Powerball ticket before. Do you know that you have a 1 in 714,924,299 of a chance of guessing the correct lottery ticket numbers? That is very, 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 very unlikely that you would actually pick the right ones. So when we've seen these probabilities, what is it? Probability is a fraction, decimal, or percent that tells how likely something has happened. What is the likelihood of an event occurring, in other words? Probability is always somewhere between impossible and certain. Impossible meaning cannot happen ever. Certain meaning it will happen all the time. In between, you have 50-50 chances, an even chance, such as heads and tails, an unlikely chance that you would guess a certain number on a dice, or a likely chance. Here you see 4 out of 5 are blue. It is likely that you would pick a blue from these 5. Likelihoods, like we talked about, start with impossible probabilities. An example of an impossible probability would be rolling a 10 on a dice. A 10 is not written on a dice, therefore you can never get a 10 when you roll a normal dice. An unlikely probability would be rolling a 2 on a dice. 2 is only one option out of 6, so it's unlikely that you would be able to guess exactly the number on the dice. An even probability would be rolling an even number on a dice. Half of the numbers on a dice are even, therefore you have a 1/2 chance of picking an even number. A likely probability example would be rolling a number 2 or greater on the dice. Almost every number on the dice is 2 or greater, therefore it's likely that you would get that. And a certain probability example would be rolling a 1, 2, 3, 4, or 5, or 6 on a dice. These are the only options that are on the dice, so it's likely that you would get one of those. It's certain that you would get one of those. We're now going to look at some vocabulary words that will lay a foundation for the rest of our lessons. The first word is an experiment. An experiment is a test in which results called data are observed. Perhaps you want to see how likely it is that you would get heads on a coin when you flip it. An experiment would be us sitting down and actually flipping the coin and recording what happens. Each time we flip that coin is called a trial. A trial is a single observation in an experiment. If we flipped the coin 100 times, it would be said that we did 100 trials. An outcome is each result of every trial. So if on the first trial we flip the coin and we get a heads, heads was the result. A sample space is the set of all possible outcomes in an experiment. If we're talking about that coin, the possibilities are we either get heads or we get tails. There are no other possible outcomes for that experiment. An event is any combination of one or more outcomes. We could say that getting heads is an event, but we could say something like getting tails 3 times in a row. That would be combining more than one outcome. When we talk about probability, there are two types of probability that we will discuss. The first is theoretical. I want you to look at the first 4 words, first 5 letters, because if you add a Y on the end, it looks like the word theory. Theoretical probability is in your head probability. It's probability that you think will happen. It is looking forward to the future. You don't actually do anything, you just think about it. Well, when I think about a coin, I think I could get heads half of the time because if there's only 1 out of 2 that are heads. Thinking about what could happen. Experimental probability is the opposite. If you look at the beginning of the word experimental, it contains the word experiment. And an experiment is something that you actually do. It is tested probability. It's probability that did happen. It's looking back to the past. It's not just thinking about that dice, but picking it up with your hand and actually rolling it. Now, we're going to talk about defining a sample space. A sample space is the set of all possible outcomes. So I want you to think about finding the sample space of flipping a coin. We discussed this a couple minutes ago. When we flip a coin, we could either get heads or we can get tails. Now we say the word or when we're talking about it, but we don't want to write that because or is not a possibility. Heads, tails. Those are the only 2 possibilities when you flip a coin. What about rolling a number cube? When you roll a number cube, you could get 1, 2, 3, 4, 5, 6. There are 6 possibilities, 6 possible outcomes in the sample space. What about guessing the number of jelly beans in a jar? Well, someone could essentially guess the number 1. There's 1 jelly bean in the jar. Or there's 2 jelly beans in the jar, or there's 3, or they could really pick any number as high as they want. So if we don't want to list all the numbers that are in order, we can put 3 dots, which is an ellipse, and then the infinitely many symbol. So we could have 1, 2, 3, all the way up to infinity. Now, these sample spaces were fairly easy to define, but other ones can be a little more complex. So there are 3 popular methods for showing the sample space. You could make a list, a chart, or a tree diagram to show possible outcomes. So let's look at this example, which is Jose. It says Jose has 2 pairs of pants, black and brown. He has 3 shirts, white, yellow, and blue. What outfits can he wear? Well, we could make a list of the possible outcomes. Okay, he could wear a black pants with a white shirt. He could wear black pants with a yellow shirt. He could wear black pants with a blue shirt. He could wear his brown pants with the white shirt. He could wear brown pants with the yellow shirt, or he could wear brown pants with the blue shirt. And you can see that I've listed 6 different possibilities for what he could wear. Now, an alternative option would be to make a chart. Now, you know that a chart has rows and columns. So when we talk about a chart, we can only organize 2 options. So for this particular situation, we can make a chart because we only have pants and shirts. Had they listed socks and had 3 different options, 3 different choices that we're making, then we could not use a chart. For a chart, we're going to need an extra row and an extra column to organize the words. So we have 2 pairs of pants, so let's make 3 rows in our chart. So here's our chart. we're going to make it have 3 rows. Okay. We are going to use the first one to write the word pants so that we know that we're listing the colors of the pants in the first column. Pants is the first choice that Jose has to make, and he has 2 choices, and these 2 boxes will represent his choices. He could choose black pants. He could choose brown pants. Now, we will use the columns for shirt choices. He has 3 shirt choices, so we need 3 more columns so that we can label the choices that he can make. He can choose a white shirt. He could choose a yellow shirt. Or he could choose a blue shirt. These 6 boxes in the middle show the 6 outfits that he could wear. Number 1 would represent black pants with a white shirt. Number 2 would represent black pants with a yellow shirt. Number 3 would represent black pants with a blue shirt. Number 4, similarly, would be brown pants with a white shirt. Number 5 would be brown pants with a yellow shirt. And number 6 would be brown pants with a blue shirt. Again, you see the same 6 outfits that you made with your list, just organized a little differently. The last way is to make a tree diagram. It also shows your 2 choices by listing them at the top. We will be making a choice about pants and about shirt. This will show the paths that he could choose. So, when we talk about his pant choices, he could choose black pants or he could choose brown pants. If he chooses black pants, he could choose the white shirt, or he could choose the yellow shirt, or he could choose the blue shirt. If he chooses the brown pants, he could still choose the white shirt. He could choose the yellow shirt, or he could choose the blue shirt. Each one of these pathways shows one choice: black pants with a white shirt, black pants with a yellow shirt, black pants with a blue shirt, brown pants with a white shirt, brown pants with a yellow shirt, or brown pants with a blue shirt. 6 different outfit options.